Okay, want to throw a quick summary at you of what we did in class today and try to move ourselves forward with linear regression. So where we start is by breaking our pencil. Then we get another pencil and we're asking ourselves, when is it appropriate, or when should we do, or when should we not do linear regression? I'm going to switch to a pen. And the first thing is that it has to be quantitative versus quantitative data. That is to say, we can't do this with categorical data. We're comparing two quantitative variables. Then we take a look at the scatter plot. And the scatter plot can tell us roughly three things. It can tell us the form, it can tell us the direction, and it can give us a sense or some rough idea of the strength. So the form, what we're looking for in the form of a scatter plot, is we want it to be linear-ish. You should read in your book, if you don't like that ish business, see how they phrase it in the book. It's kind of, is it straight enough? When we look at our scatter plot, does it make sense to consider doing a linear regression? For example, if we were to look at this data, I think it's pretty emphatically yes. That data looks pretty feasibly linear. Let's go ahead. But if we looked at this data, we would say, nope, nothing linear going on there. Next chapter, well, not actually next chapter, we just don't do a linear regression, and that's it. Is it linear-ish? Direction, our choices are positive and negative. That's slope. Strength, what we're looking at is on a scale of 1, a 0 to 1, where 1 is perfectly straight and 0 is nothing going on at all, perfectly scattered. Can we say how strong of a relationship is it, or how strong of an association is it? So if we go back to these two that we looked at before, we might look at this one and say, that's a pretty strong association. And in fact, we then calculate the correlation to be something very close to 1. You'll notice this one's 0.916. That's pretty good. Compared to this one, which we said isn't very linear looking, and now we notice the correlation slightly negative. Yeah, I can kind of see that now, but really close to 0. We're looking at negative 0.01. Okay? So that is strength. And we'll push on that with some more detail. We can calculate correlation, which is our R value, and we'll mention a little bit more of this, but that's the sum of all those. Well, I'll leave the formula out of there. That R value can be calculated, but we can also estimate it. Estimating it just gets us started. And then we need to consider whether there are outliers. Once we've looked at the scatter plot, we think it's linear-ish. Are there outliers? Outliers can wreak havoc. What I mean by that is if we compare this scatter plot, one we just looked at a second ago, it's got a linear form, positive slope, so it's got a positive direction, strong correlation, close to 1. If we drag one of those points, drag one of those points over to here, same correlation, I dragged a point way over to here, this is an outlier. It's all away from the rest of them. Look what it did to the correlation. It dropped it from 0.9 to 0.5. One data point. This is a sample size of 20, but I think you get the idea. If there's an outlier, you have to either fix it, or you can't do linear regression with this. It won't have the same. It won't have it won't be effective. It won't be useful. So you have to ask yourself, what happened with this? Did the technician fall asleep? Who was gathering the data? Was there just some crazy outlier? Was it recorded wrong? written, was it a typo? Did someone just type it in wrong after recording it? All sorts of things could lead to an outlier, and it would require some investigation in order to proceed. So if we have an outlier, not appropriate to do a linear regression. And the last thing just to kind of keep in mind is there could be lurking variables. That is to say, we don't, correlation doesn't tell us causation. Correlation, just because a correlation is strong, does not imply causation. Meaning just because there's it's a linear form doesn't mean that X caused Y. It just means that there's a correlation. And we looked at a couple examples. We talked about a couple examples of that in class. Consider the following. If you missed them in class, come ask. The following situations might have lurking variables. We said, what if we compared SAT scores to salary? We might find a correlation, but we would, I think, question the causation. We might compare height. That would be pretty interesting, to salary. Right? Again, we might find correlation, doesn't mean there's causation. And come ask. The next video, we will get into the hows. How do we perform linear regression?